Having been a top-flight UK tuning company since 1984, Torque Developments International continues to provide successful engineering solutions to motorsport and professional car enthusiasts. My name's Sam Baldwin, I'm the Technical Director here, and I have over 10,000 hours of real-world experience here in the dyno cell. I'm going to give you a glimpse at how we work here on a day-to-day basis in the world of professional tuning. What is mapping? Well, really it's tuning. It's ECU tuning. We're tuning the engine management system or engine control unit on whatever this car or motorbike or boat might be. The process of tuning engine management is really quite simple at its very core. Engines need very little to run effectively. They need fuel, roughly in the right quantity for the engine cycles that are going on, and they need a spark at approximately the right time and sufficiently strong to break hydrocarbon fuel apart and create a chemical reaction in the combustion chamber that's going to release some heat, which is going to expand some air, push onto our piston in our rotating assembly inside the engine. We're going to capture that heat energy and that pressure energy as kinetic energy on our crankshaft, and we're going to turn that crankshaft's kinetic energy into some kind of movement, useful movement energy on the outside of the engine. It's similar in basic principle to pedaling a push bike as a child or an adult. You're applying pressure to your pedals on a push bike the same way as an engine puts pressure on its pistons. Your leg, in the sake of a push bike, is performing the function of a connecting rod in an engine, and the crankshaft in your engine is very much the crankshaft and pedals on your push bike. What we're looking to do when we're tuning a running engine is to provide the next engine cycle that's coming around, the next suck, squeeze, bang, blow series of events with the required amount of fuel. And we need to gauge how much gas may have been induced into this suck, squeeze, bang, blow cycle so that we know how much fuel to put in. That's the job of an engine management system. It looks at the prevailing conditions and estimates what's about to happen. When we're tuning engine management, it's about making sure the engine management's predictions about the future are accurate. If you change your engine to make it louder, more powerful, make it rev higher, maybe make it more powerful at lower revs, whatever it is you might change about the engine's characteristic, the very next thing you need to do is let the ECU know about the change in the engine's characteristics. And this is where we get into ECU tuning. ECU tuning, another term for it, is mapping. We use the term mapping because we're going to map out the characteristic of the engine, the new characteristic of your engine. So we've spoken a little bit about how basic engine management systems might control a basic engine, just providing fuel and spark at the right time and in the right quantity. But let's talk about, for example, the new Focus RS, a modern engine management system, significantly more complex than just providing fuel and spark to the engine. In the Ford Focus RS, for example, we have an intake and exhaust cam system that can be controlled in terms of their position robotically compared to where the crankshaft is. We have a robotized drive-by-wire throttle system controlled by an electric motor, and we have a heavily electronically controlled turbo. All of this feeds in to an engine management control system that's able to completely shape the performance characteristics of that powertrain to meet the needs and wants of Ford's engineers. That engine comes out of Ford's factory with a claimed 300 horsepower. That isn't by any means the maximum power it can make. That's where Ford wanted it to hit the market. That's how they wanted to achieve their emission standards and their reliability sign-off and their miles to the gallon targets. In the aftermarket, we can choose to take more risk with the mechanical componentry. We can choose to be a little bit more blasé with our emissions targets and perhaps the amount of noise that the engine's making. We might be okay with it using a little bit more fuel in exchange for more power. It's this willingness to accept risk that can generate the difference in the claimed performance increase from one service provider to another. Mapper A may be saying he can turn your Focus RS up by some large amount of horsepower. Mapper B may be saying he can turn your Focus RS up by a fairly meagre amount of horsepower. Now, this is unlikely to be down to the talents of Mapper A being greater than the talents of Mapper B. It's much more likely to be down to mapper A being happy to accept more risk on your behalf with your car. Here at Talk Developments, we use our dyno test cell to gauge as accurately as we possibly can an acceptable level of risk when it comes to tuning a kind of car like the Focus RS. We look for components that are starting to reach the limit of their tolerance, things that are potentially getting a bit hot. And we look for components that are causing a bottleneck restriction. And we look to either re-engineer, remove, or perhaps work around those components rather than just keep turning volume knobs up and increasing pressure and increasing temperature. It's very easy with modern powertrains to take an awful lot of risk and generate a very high power output that's very impressive, but for a very short duration before it causes a mechanical failure. We're very big on really understanding the level of risk that we're accepting with every change that we make to an owner's vehicle. For us at Talk Developments, we're all about vehicle performance, not just a maximum horsepower figure on a piece of paper. For us, we spend a lot of time looking at the average horsepower that's generated by an engine, for example, across an RPM band, swept by the rev counter of your vehicle when you change from one gear to the next, as it's the average horsepower that's effective across one gear change to the next that you really feel in the seat pushing you in the back. Having a very high peak number is no guarantee of having a fast car in the real world. Here at Talk Developments, we're very keen to work with performance car owners, and we understand that being asked to work on somebody's pride and joy is a really important task. We are never blasé with taking risks with people's cars. We use our dyno cell for that exact reason. We like the car to be tuned and run in the most aggressive way that it will ever be run, under our watchful eye, instrumented, so that we can gauge the level of risk that we're applying to all of the componentry in the car, so that we know exactly what we are asking everything to do. And our aim is to take an acceptable level of risk with these cars and never an unknown amount of risk. So this may by this point be starting to all sound a little bit complex, and it is a complex subject, but I think too much is made by other people in our industry of this process of tuning engine management and tuning engines being a dark art in some way, or in some way mythical or hard. And it's not. It is complex, and it is a science. It requires some discipline and it requires some knowledge. But anybody can learn this, given enough willpower and discipline. We teach people 5 times a year in little 2-day courses to be able to tune their own engine management system on their own car. In fact, our dyno cell here at Talk Developments, whilst we're using it a lot of the time, we're happy for motorsport teams to come in and use it if they would like, and we're happy for anybody to come in and use it, and they can rent it themselves, whether that be a student who's just interested in maybe breaking into the industry later in their life, or someone who owns a project car and they would prefer to do their own tuning on their own car that perhaps they built themselves. I love that concept, and we're happy to work with anybody who wants to use our dyno. For us here at Talk Developments, our dyno cell is a critical part of the tuning process. We can't carry out our mapping or our tuning work without closing the loop here in the dyno cell to make sure everything we've done is accurate and safe and as intended. It's a complex room with lots of equipment here in the dyno cell, and in the next video we're going to look at all of the equipment that we've chosen to have here in the room, why we've chosen that particular equipment, and we're going to talk a lot about how we use it, and more importantly I think why each piece of equipment here in our dyno cell absolutely needs to be in here. There's nothing in this room that doesn't need to be here. Thank you for watching our video. I hope you found it helpful, and I hope it's shed some light on the subject of engine management mapping. If you'd like to know more about our services here at Talk Developments, our training courses that we offer on the subject of engine management mapping, check out the links in the description below. And to make sure you don't miss any of our upcoming videos, make sure you click subscribe. So welcome to our dyno cell. We're going to have a look around the whole room But the first thing I want to show you is the dyno itself. This is our rotor test VPA.